So students, this is question 2.1, exercise question of NCERT chapter 2. So we have two charges, Q1 which is equals to 5 into 10 raised to the power minus 8 coulombs, and Q2 which is minus 3 into 10 raised to the power minus 8 coulombs, and they are located 16 centimeter apart. So this distance is 16 centimeter. You can see 0.16 meters. So we need to tell that at what point on this line joining. So this line joining is this and then this and then this. This is the line joining. So line, this is line. So line is infinite. Its length is infinite. Line segment means part of the segment, but here it is line. So students, the potential, as you know, we need to tell where the potential is zero. First thing is that potential is a scalar quantity. So simply we need to add two numbers and their sum must be zero. So obviously one number will be positive and one number will be negative, because this is positive charge and this is negative charge. So potential due to positive charge is positive and potential due to negative charge is negative. Okay, let me remind you once again, as we are at the end of electrostatics, we have studied the Coulomb's force, that is K Q1 Q2 by R square. So students, this is of course a vector quantity, but it's better find the magnitude and then tell the direction. If the same charges, they will repel, and opposite charges, they will attract each other. So that is why we put the this modular sign over there. So when I'm finding the magnitude of force, I'm not concerned with the charges, means the negative or positive charge. I'm only concerned with the product of the charges. So don't put negative, positive here. Just find the force and then tell the direction. Same is the case with the electric field. In electric field also, don't put the sign of the charge. In Coulomb's force we know Q1 Q2. If Q1 Q2 is greater than 0, so means they are both positive or they are both negative, so there will be repulsion. And if Q1 Q2 is less than 0, then there will be attraction. So direction, it's better for the vector if you can find the magnitude and direction separately, that's better. So here also we can do the same thing. For positive charge, field lines are outward. For negative charge, the field lines are inward, so we can tell the direction. So here we need not to put the charge, means the symbol, means negative or positive thing. But now let us come to the potential energy. So simply remove, means there will be 1 R here in the denominator, and then V, that is U by Q. So E is F by Q and V is U by Q, right? So that's equals to K Q by R. So here Q1 Q2 you can take it as Q and Q also, that's your choice. So what I want to say is that for U and V, I have not put the modular sign here. So you need to, so these are scalar quantities, these two. So these two are vectors, electric field and force, but potential energy and potential, they are scalar quantities. You need to put the sign of the charges here. So put sign of charges in the formulas of V and U. Okay. For F and E, you need not to put the sign of the charges. Just find the magnitude and tell the direction separately. Okay, fine, good. So another thing, is so students, now there is another thing, that for this V to be 0, you need two equal quantities, plus x and minus x, then only the sum can be 0. Okay, so both are equal and with opposite sign. So how can it be possible? So this is because the formula of V is kq by r, and k we know is equals to 1 upon 4 pi epsilon naught. So that is Coulomb's constant. Now, so this is constant, so we are left with q and r. So obviously this q is lesser, so I want potential to be more. This q is lesser, so I need to further decrease the distance. Okay, then only this V will be greater. So obviously some of the time in NEET or in JEE Main the question comes on which side it will be. So obviously it will be more towards this side, not in the middle, but the point will be somewhere over here. Have you understood this concept? Now the next thing is that here also will get another chance on this side of the smaller charge. So here this V will be positive and this will be negative, but this is near, so R is lesser, so V will be more, so V will be more here, and here this will be, so on the smaller charge side we will get, so we will have 2 points over here and over here. Now let us find out this point first. Let this point be P, and you can let this point as Q. So let this point be O and A. Okay, so we have two charges at O and A. So potential at P is equals to potential due to Q1 plus potential due to Q2. As they are scalar quantities, so we can add them. So V at P, we already know that it is 0. So V1 plus V2 will definitely be 0. How much is this distance? If this distance you are letting at x, this will be 0.16 minus x. Okay. So V1 K, what is Q? 5 plus 10 is to the minus 5 into 10 is to the minus 8 coulombs, divided by R is 0.16 minus x, plus V2 K into minus 3 into 10 is to the minus 8 divided by x. That's equals to 0, right? So divide both sides with K. So both sides with K, K will cancel out. Now divide both sides with 10 raised to the power minus 8. This will also be cancelled out. Now take this minus 3 by x to this side. So what do I get? I get 5 upon 0.16 minus x equals to minus 3 upon x. Now cross multiplying them. So 5x is equals to minus 0.48 minus so plus 3x. So this will comes out to be 2x equals to, so what's the problem here, students? This is supposed to be of course positive, So what's the problem? So this minus 3, I'm taking this side, so it will become positive. Obviously x is supposed to be positive only. So this is minus 3x, right? So minus 3x will come this side and this will be 8x. So the 8x is equals to 0.48 and x equals to 0.6. 0.06. So 0.06 meters. So x equals to 6 centimeter. So I was telling you that yes, of course, this is 6 centimeter and this is 10 centimeter. This is 6 centimeter. Now what about V at Q? This is also 0. We are assuming it to be 0. And then we have to tell this distance, how much is AQ. Okay. So we have the charges here now, Q1 and Q2, and this is my point Q here, and so this distance was 0.16 meters. Let this distance be x this time. So the potential at Q is 0, so that will be equals to V1 and V2. So V1 plus V2 is equals to 0. That's the potential at Q. So what is V1? So V1 equals to K. Q is 5 into 10 raised to the power minus 8 divided by how much is this distance? This distance is now 0.16 plus x minus Q2. So that is K into minus 3 into 10 raised to the power minus 8 divided by x. That's this distance. And that's equals to 0. So students, you can solve it in the similar way and you will find that here x comes out to be 24 centimeter. So this you can do, right? So this was question number 1. And now next question. Question number 2. So question number 2, we have a regular hexagon of side 10 centimeter and which has a charge of, so on each of the vertices of the hexagon, so this hexagon, and on each of the vertices we have charge 5 microcoulomb. So 5 microcoulomb everywhere. And we need to calculate the potential at the center of the hexagon. So same as we have done above, potential due to all these points. So the main thing is that what is the formula do we have for the potential? So KQ by R. See, the distance we are finding, this is O, so we are finding the potential. So this distance is R, this is R, this is R, this is R, this is R, this. So all the distance are same, right? Q equals to 5, so that is also same. Okay, and this is constant. So obviously, so this is the potential due to, suppose, any one of the charges. So net potential will be 6 multiply V1 because the potential will be same, contribution will be same. So now our main target is just to find this R. So this is a equilateral triangle in hexagon, students. So this equilateral triangle, and we have the side of 10 centimeters given. So this is 10, this is 10. Of course, this will also be 10. So equilateral triangle, so this is perpendicular bisector. This side is 5 centimeter. And So we don't need this side, right? This R, and this is 10. So this will also be 10. So R equals to 10 centimeter. We don't need this perpendicular, right? Okay. So that's equals to 6 into K is 9 into 10 raised to power 9 into the charge is 5 into so 5 into 10 raised to power minus 6 coulomb divided by the distance, that is 10 centimeters. So students, you are supposed to write it in meters, and this you will get as 2.7 into 10 to the power 6 volt. So remember this property of hexagon, that its diagonal bisect each other and they form 6 equilateral triangles. Now third question. Two charges plus 2 microcoulomb and minus 2 microcoulomb are placed at points A and B, which is 6 centimeter apart. You need to identify the equipotential surface of the system where the potential is equal. So where will the potential be equal? So obviously we'll have this a plane over here, right, which is dividing this in two parts. So on this plane, at every point will be equidistant, isn't it? All the points are equidistant from A and B on this plane, which is in the middle of the line. So middle of the line means 3 centimeter from this side and 3 centimeter from this side, because we know that V is equals to KQ by R. So the Q, magnitude of Q is same, and in the middle this R will also be same, and K is the constant. So potential due to plus 2 will be plus, and due to this will be minus. So this on this plane, so this is equipotential plane, and what is the potential over here? 0. So exactly cancelling out. So this is the midpoint of AO. So equipotential surface so if this is the point at A, so potential at O, VA this and VB will be K minus Q by R. Okay, so what is the net potential? VA plus VB, that is equals to 0 at O, at the center, right? Because R is same, 3 centimeter, 3 centimeter. So what will be the equipotential surface? So equipotential surface will be a plane normal to this line AB, passing through midpoint O, right? And V will be 0. Everywhere on this plane. Okay students, so that was the first part. Second part is, what is the direction of electric field at every point on the surface? So what is the direction of electric field? So from positive charge, the field lines are, say this is, isn't it something like we have these two plates, this is positive charge and this negative charge, so that is the direction of field lines, right? So here also this is positive and this is negative, so obviously the direction of field line is from positive to negative. So at this point, electric field is not zero, students. Why? Because electric field at this point, I told you that electric field find the, so here take the magnitude only, so magnitude will be same for both of them. Now let us find the direction. So direction at this point, at the midpoint, even if I have two charges, this plus, this is negative, their charges are, they are equal charges but opposite in sign. So this is my midpoint, okay, all right, this is R, this is R. So midpoint O. So E will be this for both of them. So now let us find the direction. Is the direction cancelling out? Because here the VA was positive and VB is negative. So here we need to see the direction. So direction due to plus will be, is the direction due to plus charge, and what is the direction will due to minus charge? That will also be in this direction, so towards the negative and away from the positive. So that's the same case when we find the electric field between the lines and the capacitor. So field actually added up. So here also field will be added up. So field will be 2k q by r square. So this was the field due to positive charge. So net field, this will be added up. And what's the direction? So direction is obviously towards the negative charge. Okay, so that's another important concept. So direction of electric field from positive to negative. So electric field is not zero. Good. Now let us do next question, 2.4. So students, I'm not only teaching you the means just calculating the solutions, but I'm teaching you the concepts, all the concepts which are related, so that even you'll be able to solve MCQ questions, because we will have 50% of the MCQ questions. So you need to have the concepts very clear. Okay, next question. So we have in the next question we have a spherical conductor of radius 12 centimeters. Spherical conductor is not has been removed from the syllabus, but still you can have this question. So a spherical conductor, okay, electric field for the spherical conductor, which is application of Gauss law, is removed, but this question can be there. This is related with the same concept, but let us do this question. So 12 centimeter, it has a charge uniformly distributed over the surface. So the charge is 1.6 into 10 to the power minus 17 coulombs, and it is uniformly distributed all over the surface. What is the electric field inside the sphere? So students, what is electric field inside the sphere? A point. So this is actually the application of Gauss law, this electric field inside the sphere. But still, electric field as this charge is uniformly distributed, so electric field anywhere inside the sphere will be zero. Okay? Good morning, ma'am. So you need to remember this point. Okay, next is what is the field just outside? Just outside I am asking. So just outside the sphere, what will be the field? So students, just outside, this is the radius. Just outside means just on the surface. On the surface, little bit away from the surface, just outside. Okay. Now, do you know that when this sphere, it will behave as if the whole charge is placed at the center O. This is how this charge is going to behave. So how this charge which is uniformly distributed over the surface of the sphere will behave as if the whole charge is concentrated, as if this whole charge is concentrated at the center O. Okay? And now we have to find the field just outside. So then only it will behave at this point. Okay? So just outside means same distance, that is r, that is the radius. That is equals to 0.12 meters. And now we have to find the electric field. So what's the formula of electric field? E is equals to, I told you, K Q by R square. So that's equals to 9 into 10 to the power 9 into 1.6 into 10 to the power minus 17 coulomb divided by 0.12 whole square. So students, this will comes out to be 10 to the power 5 Newton per coulombs. And what will the direction? So direction will be outward. So I told you this is the magnitude, find the magnitude separately and then tell the direction. So direction is outward. Okay. Now C part of this question. What is the electric field at a point 18 centimeter from the sphere? So 18 centimeter from the sphere. So the only thing is that now it is 18 centimeter. So initially it was 12 and now 12 to 18. So the only thing is that put here E equals to E at 18 centimeter. You can write it E dash also. So 9 into 10 to the power 9 into 1.6 into 10 to the power minus 17 divided by 0.18 whole square. So you need to divide this by, so when you will find this, you will find the answer to be 4.4 into 10 to the power 4 Newton per coulomb. So that's the concept, students. I hope you have got it. Now the next part, next question, 2.5. A parallel plate capacitor with air between the plates has a capacitance of, so we have the vacuum between the plates here. Air is almost same as vacuum, same permittivity. Okay, and what's the capacitance of this capacitor? 8 picofarad. I think we have done this question yesterday also. So 8 into 10 to the power minus 12 farad. It's equals to now what will be the capacitance if this distance d, if this distance d is reduced to d by 2 and the space is filled with dielectric constant, and dielectric constant is 6. So what is the formula for this? C naught is equals to epsilon naught A by D. And what is the formula for this capacitance? So here this was for the permittivity of free space, but here this is the permittivity for this dielectric is. So remove E naught. So naught is for air. So A by, and this is D. Suppose this we can write as D dash. So area is same. So, and this is equals to 8 into 10 to the power minus 12 farad. Now we have to tell how much is this. So this will be C dash, or even C is all right, because this is C naught, and so C dash is also C or C dash, that's your choice, whatever you are taking. So students, what is C dash? That is equals to, so what is this? Epsilon is equals to, so that's epsilon naught into K, okay, and that's A upon, what is D dash? D dash is D by 2. So this capacitance of this capacitor comes out to be, so epsilon naught A by D, we know the value, So epsilon naught A by D. This 2 will come upside. So 2K into 8 into 10 raised to power minus 12 farad. And how much is the K? K is 6. So 12, 8 the 96. So 96, and this is farad, so minus 12 is picofarad. Okay students, so you need to be quick while doing these kind of questions. So next question is 2.6. So we have 3 capacitors and they are connected in series. So students, we have 2 concepts. One is this capacitor connected in series, and we have resistance connected in series. We have capacitors connected in parallel, and we have resistors connected in parallel. So one thing is sure, that in parallel voltage is same in both the cases. Okay, so we have the formula that C is equals to Q by V, and here we have the formula V is equals to IR. Okay, so here in parallel current is divided. So here the current is divided in resistances. So here I have, because this is the current I, and then Kirchhoff's junction rule, so this will be I1 and this will be I2. So current is divided. In series, current remains the same. So that's for the resistances. So same is the case here. V is same and Q is divided. So this charge is divided. This is Q1, this can be Q2. Here, so here the potential was divided. So here again charge will be same and potential will be divided. So here the same thing that which is for the current, same thing here for the charge. Okay, good. So you can write this formula that R is equals to I by V. But the difference in formula is that here for the capacitance is equals to, in when they are in parallel it's C1 and C2, when they are in series it's 1 by C1 plus 1 by C2, whereas here for resistances R1, R2 we have in series R is equals to R equivalence resistance equal to R1 plus R2, and for voltage is equal to V is equals to V1 plus V2. Sorry, I is equals to I1 plus I2. So I equals to I1 plus I2 here. So resistance 1 by R for parallel, 1 by R is equals to 1 by R1 plus 1 by R2. So capacitance for parallel, C is equals to C1 plus C2, but for parallel here. So this formula is reversed, right? Now we have these 3 capacitors, and they have all of them have the same capacitance, 9 microfarad, 9 microfarad and 9 microfarad. Students always try to draw the diagrams. What is the total capacitance of the combination? So total capacitance of the combination will be 1 by 9 plus 1 by 9 plus 1 by 9, that is equals to 3 into 1 by 9. So this will cancel out. So obviously this is 1 by C, and C will be 3 microfarad, right? So that's the equivalent capacitance. Now we need to tell that it is connected with 120 volt supply. So this will be divided equally, right? So this will be V. So let potential drop here be delta V, delta V, delta V, or you can write V also, or V dash. If this you are assuming as V, then this is V dash. So as the capacitance is same, so the drop will be same. So 3V dash is equals to 120 and V dash is equals to 40 volt. So the potential difference is 40 volts. So this is the net capacitance of the circuit, and this is the voltage drop across each of the capacitor. Next question. So we have three capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad, which are connected in parallel. So this is the diagram that we have. So this is 2 picofarad, this is 3 and this is 4. And they are connected. Okay, they're connected in parallel. What is the total capacitance of the combination? So it's so simple. So normally we connect the voltage here. So these questions are very simple. So what is the total? So in parallel, C is equals to C1 plus C2 plus C3. So add all of them, 2, 3, 4. It is 9 picofarad. So that's the total capacitance of the circuit. Now what's the next point? We need to determine the charge on each capacitor. If 100 volt supply is connected, okay, so what's the charge on the capacitor? So C is equals to Q by V. So V will be same. So here it will be 100 volt, here also it will be 100 volt, here also it will be 100 volt. But the charge will be divided. So here the charge will be on this capacitor, let on this capacitor will be Q1 and Q2 on this capacitor and Q3 on this capacitor. So C is equals to Q by V, and Q1 will be equals to C1 V, because V is same. So capacitors, as their capacitance is different, we can write them C1, C2, C3. So Q1 is equals to CV1 by this formula, and Q1 is equals to C1 is 2 picofarad into 100 volt. So let this pico prefix be like this only. So this is 200 pico coulomb. So you can write it like this. So 10 raised to minus 12 and this. So this can further be reduced to 2 into 10 raised to power minus 10 coulombs. Similarly, Q2 will be C2V, and what is C2? This is 3 picofarad into 100 volt. So similarly, you can write this as 3 into 10 raised to power minus 10 coulombs, and Q3 will be equals to C3V, that is equals to 4 picofarad into 100, and that is equals to 4 into 10 raised to power minus 10 coulombs. So now next question, 2.8. Students, in this exercise you will have questions in your board exams from the additional exercise also. So there are certain questions of capacitor. So the circuit which has capacitors, so you will have questions on them. We'll do the questions, those questions, if not today then tomorrow. In a parallel plate capacitor with air between the plates, each plate has the area. So we have the parallel plate capacitor and the area of the plate is given to us. that is 6 into 10 to the power minus 3 meter square. And the distance between the plates is 3 millimeters. So distance between the plates is, this d is equals to 3 millimeters. Calculate the capacitance of the capacitor. So the capacitance of the capacitor is so simple, epsilon naught. If you have A and D, we have this formula. So this is Q by V by definition of the capacitor, capacitance, and this for the parallel plate capacitor. Where if A and D is given to you. So you need not to do anything, just put the values, epsilon naught, but the values must be in SI unit. So 6 into 10 to the power 3 meter square is SI unit, fine. So epsilon is 9 into 10 to the power 9 divided by D. So 3 milli means 10 to the power minus 3 meters, and so this will comes out to be, so don't write the units here if you are not writing units at other places, because you are not writing units here. So this will comes out to be, okay, this is the value of K, student, this is not the value of epsilon. So value of K is 9 into 10 to the power 9, that is Coulomb's constant, but the value of permittivity of free space is 8.85 into 10 to the power minus 12. Okay, I'm not writing the units here. So C is equals to epsilon naught is 8 into, so this will be given to you in your exam, this value, otherwise remember it, 8.85 into 10 to the power minus 12 into area 6 into 10 to the power minus 3 divided by 3 into 10 to the power minus 3 whole square. Y square, it's only D, right? So this comes out to be 1.8 into 10 to the power minus 11 farad. So this you can write it as 18 picofarad. So students, we have another part of this question. Calculate the capacitance of the capacitor. We have done it. Now this capacitor is connected to 100 volt supply. So this capacitor is connected to 100 volt supply. Okay, what is the charge on each capacitor? So when we connect it to 100, it will start charging. So it will start charging, and how much? So there will be minus Q and capital Q on the plates. So what is the charge? So now we'll use this formula. We know the capacitance. So when we are dealing with charge, we'll be using this formula. So capacitance is 18 picofarad is equals to, charge is we need to calculate and multiply by 100. So this comes out to be Q equals to 1.8 into 10 to the power minus 9 coulombs. Okay. So next question. 2.9. So we need to explain what would happen if in the capacitor which was given in this above example, if a 3 millimeter mica sheet, so how much was the distance between the capacitor? 3 millimeter. So it means the whole capacitor is covered with the mica sheet is dielectric, it is dielectric material, and its dielectric constant is given as 6. So what will be the, what would happen actually, you need to tell. So what would happen, you know that for the capacitance here was this, so this was C naught, you can, because now you will write this as C, so in the air or vacuum, so it's better to write this formula, C naught is equal to epsilon A by D, and here it will be epsilon A by D, and that will be equals to, we have done this kind of question earlier also, A by D, so that's equals to So what's the value of epsilon naught A by D? Epsilon naught A by D is 18 picofarad. So 18 picofarad into 6. So 6 into this. So the main thing is that it will be the 18/6, the 96. So students, we need to find when the voltage supply remains connected. So this will be the new capacitance, and so when the supply remains connected, 18/6, the not 96, it is 108. So what will be the charge on the capacitor? So students, instead of writing this formula, can we simply write C is equals to this is your K, and epsilon naught A by D is C naught. So yes, we know this formula. So K is equals to C by C naught. That's equals to epsilon by epsilon naught also, but we did it yesterday also, this formula. Okay, so it's better directly write this formula. So this was your K and this was your C naught. So K into C naught. Okay. Now, what is the charge on the capacitor plates? So Q is equals to C into V. So we know the value of C, that's 108 into 10 to the power minus 12 farad into the volt that we have connected with 100. So that comes out to be 1.08 into 10 to the power minus 8 coulombs. So earlier it was 10 to the power minus 9 coulomb, now it is, so more charge will be there. So Q is equals to CV, right? Now the supply is disconnected. What will happen? So of course, this capacitance is the intrinsic property. So it is independent of what voltage you are providing. C will remain the same. So second part of this question. So C will remain the same. C will remain 108 picofarad, but what will be the now? So now the supply is disconnected, so the potential difference between the capacitor plates will become V is equals to V naught upon K. So K is equals to V naught upon V. Okay. So this will comes out to be, so V naught was 100 volt. So 100 volt divided by 6 is 16.6 volt. So after the supply will be disconnected, then this will be the potential difference between the capacitor plates. Now the next question, 2.10. A 12 picofarad capacitor is connected with, so this power supply is 50 volt, and this is 12 picofarad. How much electrostatic energy is stored in the capacitor? So we know the formula of electrostatic energy stored, that is equals to half CV square. So C is given to us, V is given to us, very simple. So half into C is 12 into pico is 10 to the power minus 12. So just take care of units, SI units you have to put into 50, and don't forget to put the square, and this will comes out to 1.5 into 10 to the power minus 8 joules. So let us do one more question. So a 600 picofarad capacitor is charged by 200 volt supply. So we had this this was charged with 200 volt. This is 600 picofarad. So the 600 picofarad is the capacitance. And then it is disconnected from the supply and it is connected with another 600 picofarad. So how much is the electrostatic energy lost in the process? So students, we did this type of question yesterday also, right? So this is same as the example which is there in your book. So last example in your book, in your NCERT book, last example, it is similar to that. So in that question you had 900 picofarad and it was connected to 100 volt. So this I am talking about example 2.10. So we did it yesterday, okay? And the videos are there on the channel, so you can see yesterday's video if you want to see. And how much is the electrostatic energy stored? So we calculated the energy stored, and that's equals to the energy stored was, so we have the capacitance and we have the voltage. So the formula is half CV square. We have another formula also, half QV also. So half CV square we can use, and that comes out to be 1/2 into 9 into 10 raised to power. So this is pico, so 10 raised to power 900. So 900, how much is the left is 10 raised to power, because 10 raised to power minus 12. So this will be supposed to be 10 raised to power capacitance stands for minus 10. So 9 to 10 raised to power minus 10 into V square. So V is 100, so 100 square. So this comes out to be 4.5 into 10 raised to power minus 6 joules. And now same case, another was, so this 100 volt was removed and it was combined with another capacitor of the same capacity, and then the total energy of the system. So in this case Q was divided. So here it was charge Q. So here the charge was Q/2 and Q/2, and the voltage remains the same. No, voltage will also be divided V/2 and V/2. So charge will be divided and voltage will also be divided. So what will be the new potential energy? So new potential energy will be equals to, so now use this formula, students. You have used this formula to do these calculations, but now you are using this formula. So that is the thing that you need to keep in mind. So that's half into, so what is this new? So Q has also become, and V has also. So this is it. So here this voltage, I think voltage is, so what this comes out to be, storage. Okay, so this is the energy stored by one capacitor, right? This is energy stored by one capacitor. And what will be the total energy of the system? So system's potential energy. So what you will be writing with? So this is for one capacitor, right? So potential energy is again a scalar quantity. So system's potential energy. So don't. It will be simply twice. Can I write? Multiply 2 here. So systems, so this was of one capacitor and multiplied with 2. So this is the system's potential energy. So this system's new potential energy of this system is, so 2 will cancel out. And this is 1 by 4 QV. So initially it was half QV, so this is half of the original energy. So students, you can directly, you will have MCQs directly in your NEET or even in CBSE also. So in this system, the potential energy is reduced to half. So similarly, you can do this question here also. U is equals to half CV square, that is equals to half QV. So use this formula, half CV square. So half into C is 600 picofarad, 10 is for minus 12 farad into 200 square. So this, so obviously I'm using this formula over here. And this will comes out to be, so 200 multiply by 200 also you can write. So 1 2 will be cancelled, and now you have 6 to the 12, and how many zeros? 2 and 2 4 and 2 6. This stands for minus 12 farad. So this will be, so it's in joule, the energy, now the unit will be in joule. So you will have 12 into 10 to the power minus 6 joules. So this will be the energy that you will have. And now I told you that this energy will be reduced by half by this formula. I told you that the capacitance is the same, but voltage will be divided and the charge will also be divided. So the new capacitance, so the new energy of the whole system is U by 2. So where has the energy gone? Because this charge was moving from this plate to this plate, this positive charge over here, negative here, positive here, negative here. So when these charges move, they lose energy. Moving charges, they are accelerating. So these accelerating charge particles lose energy in the form of electromagnetic radiations, and that's how the energy is lost here. So energy remains half of this. So what is the energy of this? So we have done this derivation, so you can, if you want to write, you can write it again, that U dash is equals to twice means for both, and what is the energy of one? That is half QV. So that is half into V by 2 into Q by 2. So you get this. So this half QV will be your U, and this 1 2 will be cancelled out, and this 2 will come here. Okay, so U dash is equals to 6 into 10 to the power minus 6 joules. So you're left with half of the energy. So students, that's all for today. Thank you for being with me.